a geologist, a physicist, and a chemist walk into a meeting of the American Association for the Advancement of Science and announce that they have evidence of global devastation caused by an asteroid impact 65 million years ago, which wiped out the dinosaurs. It's 1980, and you are all paleontologists. So as such, you know that Earth's geological processes are slow. Extinction events happen over 1 million years, and the risk of impacts from space affecting life on Earth is an idea we threw out a century ago. Science, at its heart, is a meticulous and gradual expansion of the breadth of our knowledge. But sometimes science is looking in the wrong direction, and it takes a new discovery, often from an unrelated discipline, that spins us 180 degrees. A pivotal moment, opening up new opportunities for discovery. This story centres around a series of pivotal discoveries which lead to a paradigm shift in our understanding of a pivotal moment in Earth's prehistory. In 1960, Eugene Shoemaker, a geologist, made an important discovery at Meteor Crater in Arizona. Until that time, craters were thought to be remnants of volcanoes here and on the moon. But Shoemaker found coesite, which is a shocked quartz, which is normally formed deep down in the earth in the intense pressures and temperatures. On the surface, though, it's caused by the intense pressures and temperatures from an impact from space. He also noticed that the structure and form of the crater was similar to those of the blast zones around nuclear test sites. And so he was convinced that this meteor crater was caused by an impact from space. And so he, with his wife Carolyn and colleague David Levy, conducted a systematic analysis of the inner solar system, looking for asteroids and other objects that took them sort of near and through Earth's orbit. And what they found was an amazing amount of risk that no one had ever considered before. What we know now is that there are around 20,000 near-Earth asteroids that are known to us, and about 900 of them are bigger than a kilometre. An impact from one of those is enough to make a pivotal moment in anyone's day. So while Shoemaker was focused on the risks of the inner solar system, another pivotal moment was slowly developing in Italy. In 1977, another geologist, Walter Alvarez, was fascinated by a 0.5 centimetre layer of reddish clay sandwiched between two ancient layers of limestone at a point where the dinosaurs disappear from the fossil record around 65 million years ago. Alvarez sought out his father, Luis, who was a nuclear chemist and Nobel laureate, and Frank Azzaro, who was a nuclear chemist, to help analyse this reddish clay. And Lewis thought the answer may lay in the accumulation of space dust. See, every year, 30,000 tonnes of space dust falls to the Earth. It'd be a lot if you swept it up into a pile, but it's microscopic, spread across the globe. Space dust and asteroids contain elements not found much in the Earth's crust, elements such as iridium. And so they analysed the clay for signs of iridium. And what they found was a concentration 300 times that of normal background levels. Similar samples taken from around the world from the same layer in Denmark, France, Spain, New Zealand, Antarctica demonstrated that the iridium layer was worldwide and highly elevated everywhere. Clearly a pivotal moment. Something big, abrupt, and cataclysmic happened here. The Alvarezes theorised that a comet or asteroid of a suitable size impacted with the Earth and vaporised, causing global devastation which wiped out the dinosaurs. Their announcement in 1980 was seen as heresy, particularly by the paleontologists. Now, the one thing that would back up their theory, a suitable impact site, was the one thing that they didn't have. So we need to fast forward through to 1990, as interest was developing in an unexplained ring formation underneath Mexico's Yucatan Peninsula, centred near a town of Chicxulub. The rings are 180 kilometres wide and 20 kilometres deep, and were originally thought to be volcanic in origin when they were discovered in the 50s by oil geologists. But analysis revealed by 1991 that the ring formation was the same age as the iridium deposit, and likely caused by an asteroid 11 kilometres across. Now, the only question worth answering here is, how does an 11-kilometre wide rock devastate a planet 13,000 kilometres in diameter? This is where the Shoemakers and David Levy return to our story with their discovery of comet Shoemaker-Levy 9, which was due to impact Jupiter in 1994, a pivotal moment in human history to be able to witness a cosmic collision, thanks especially to the brand new Hubble Space Telescope. One of the fragments of the comet, well, I say fragments, it was the size of a small mountain, impacted the Jupiter surface with a force of 6 million megatons, about 75 times the entire Earth's arsenal of nuclear weapons at the time. It caused wounds in the Jupiter surface, and the resultant plume of dust could be tracked in the clouds of Jupiter for weeks and months afterwards. This was the final blow for any doubters of the Alvarez theory. Unfortunately, Luis Alvarez died in 1988 and never knew of the Chicxulub crater or the impact with Jupiter. And Eugene Shoemaker died 3 years after the Jupiter impact in a vehicle accident in the Tanami Desert, continuing his research looking for other impact sites. Part of his ashes were sent to the moon on the Lunar Prospector craft, and the rest was spread around Meteor Crater. In 50 or 100 years' time, much of what we know today will be either misguided or wrong. Sometimes it takes a pivotal moment and a different discipline to rock us out of that world and let us take that next step in our understanding of our pale blue dot in this vast cosmos.